Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
Still in Oslo, Norway at NDC and in the Fishbowl. Scott Wlaschin is here. We're going to talk to him about F# and functional programming. I'm sure F# will come up. But first, we have this little thing that we call Better Know Framework.
Awesome. All right, dude, what do you got?
A very appropriate namespace.
Oh.
System.collections.immutable.
Interesting.
Yeah.
And this is just part of this framework now, is it?
Yeah. It's in .NET 4.5.
Okay.
And interfaces and classes that define immutable collections, like immutable array of t.builder, a writable array accessor that can be converted into an immutable array of t instance without allocating extra memory. So, you have some data that you want to just use, but you don't want to change. There you go. System.collections.immutable. And there's dictionaries and hash sets and lists and sorted dictionaries and sorted sets and all of that stuff.
Lots of choices.
Lots of choices.
And the real question is, what does it give us if we go immutable? Is there actually some tooling built in it that's actually going to do good things?
Well, immutability is a really good way to do asynchronous programming and to do multi-threaded programming because, that's where you really get in trouble. And I'm sure our guests can fill us in on more of the details. But there you go.
Awesome.
I think that's a good find, and we'll learn more about how to use it, I'm sure.
All right.
Yeah, who's talking to us, buddy?
Grabbed a comment off of show 1375, which we did back in November of 2016, talking to Scott Nimrod about F# for mobile development.
Yeah.
Lots of comments on the show, some mobile related, some not, and some, very focused on functional. This comment comes from Adam Wright, who says, great show. I think Scott made some excellent points about F# here. I have played with F# a bit after work for a few months now. My admittedly immature view about functional programming is that the goal is to separate functions that change state from functions that don't. Most functions probably won't change state at all. In OO, in my opinion, it's all about how we build software for the inevitable change. Encapsulation, for example, lets us only expose the contracts of the rest of the world that we want them to depend on. And the same for polymorphism. These things allow us to change and write new code so that our contracts are still intact, but the behavior of the system can change to meet our new requirements. The language you choose, C# or F#, as two specific examples, neither restrict you from using OO principles like encapsulation, nor functional principles like separating methods of functions that can change state to methods of functions that don't. You can do functional OO, because OO doesn't mean you have to have classes, although F# supports them. You can do functional programming in C# also. And as mentioned by others, F# can interop with any .NET library, not just those written in F#.
Yeah.
The F# is C# without all the ceremony. I don't know. I think it's more different than that. Mad's a crew on the C# and VB design team, I think, believe this too is they're removing more and more ceremony for the C# language with each release. Yeah, okay, wouldn't argue that.
Yep.
One example is expression-bodied members and expression-bodied functions. This is very similar to how you program in F#. No curly braces, no side effects, just functional expressions. And they've also started to add pattern matching, proper tuple support. F# isn't that hard to get started in. It's all the .NET you'd like and know. And with simpler syntax and very little ceremony, thanks again for the great show.
Yeah.
All right. No argument with me there, Adam.
Right.
I think it's definitely making some progress. We definitely had shows where we didn't talk about functional C# as a programming style. It's just a question of whether the tooling's making it easier or harder for you to pull it off.
Yeah, that's right.
And so a .NET Rocks mug is on its way to you. And if you'd like a .NET Rocks mug, write a comment on the website at .NETRocks.com or via any of our social media, because we publish every show to Facebook and Google+. And if you comment there and we read it on the show, we'll send you a mug.
And definitely follow us on Twitter. He's at Rich Campbell. I'm at Carl Franklin. Send us a tweet. We don't change them at all.
Immutable tweets.
Immutable tweets.
I like
tweets
that.
are immutable.
There
actually.
it is.
You cannot edit them.
Are they really? I guess you can delete them.
You can delete them. You can't change them.
That's true.
Once they're out there, they're there.
They're out there.
Unless there's some technology that I'm missing, you know,
Right,
like
we don't know.
tweetrecall.com or something.
Yeah,
I don't
tweet
know.
edit.
Who knows? Anyway, let's bring on our esteemed guest today. Scott Wlaschin has over 20 years experience in software development, design, and architecture, covering all aspects of business software. He's the creator of the popular F# website, fsharpforfunandprofit.com, and has done many F# presentations at conferences and user groups all around the world. Welcome, Scott.
Thanks, I'm glad to be here.
Glad to have you.
I love F# for fun and profit. That's awesome.
Oh, thanks very much.
How long has this thing been around?
Actually, I think I started it in 2012.
Okay.
So maybe 5 years. And I started it, first of all, I recommend that everyone who's thinking about writing a blog should actually start writing a blog. People told me that you should write a blog, and it's been the best thing that I did.
No kidding.
And one of the reasons I started it is I wanted to learn F# myself because I didn't know anything about F#. And the best way to learn something is to explain it to somebody else.
Sure.
So if I write down, it's like, okay, how do I explain this? And I do it. And that's what I did. Basically, every post was some feature that I figured out, and I sort of documented it for myself,
Right.
and other people have found it useful. That's great.
I think Scott Hanselman said that once as well, that he writes his blog as his own record keeping for himself.
Yeah, sometimes I Google things and I come back to my own blog and say, oh, that was really useful. I'm glad I wrote that down.
Yeah, that's got to be a moment when you Google for something and find your own blog
That's
post
right.
on it.
I do that all the time.
Yeah, I forget things 6 months later,
Sure.
and it's nice to, when I've learned something, to put it down on paper, as it were.
Yeah,
and so that
one would say that's luxury, right? That you can actually get it out of your head because you have it somewhere else.
Exactly, right.
Yeah, it's very, very compelling. Where do you come from in terms of programming? Because F# you've only come to the past few years.
Yeah,
but before that,
when I started programming in the late 1980s, and the first programming language I ever did was DBase 2 on a KPro, so that sort of dates me.
DBase made me a lot of money.
Yeah, DBase. I think DBase 2 is actually a great language for learning. And then I did Turbo Pascal, and then I started getting. I always like learning new languages, so I learned Prolog.
Right.
Nice.
And I learned a language called Icon, which is influential on Python. And then I really got into Smalltalk, of all things. So I've gone from one extreme to the other.
Yeah,
the most object-oriented
you
language.
like changing gears.
Well, actually, I still love Smalltalk, and I highly recommend everyone learn Smalltalk, because the kind of object-oriented programming you do in C# or Java or whatever, to me, that's not object-oriented programming.
Yeah.
Real object-oriented. So I'm going to be an object-oriented programming snob and say, you're not doing real object-oriented programming until you've used Smalltalk. It's a different way. It really is a different way of thinking.
It was really the first, wasn't it? Object-oriented.
I think
real
Simula
object
was technically the first one, but Smalltalk is probably the most influential one in terms of...
Yeah, I remember spending time with Eiffel, too.
Eiffel's very cool. Yeah. I think there's two strands of object. There's the kind of C++ style, which is like C with objects,
right,
or Pascal with objects. And then there's
an existing language that tries to add in tooling around object operations. And then
using existing. Smalltalk has a very weird model. It doesn't have source code. It doesn't have files. It doesn't have any of the stuff. You can't edit it in Vim. It's an image.
Right.
It's like actually the nearest model would be like a container, like a Docker container or something.
Oh, yeah.
And you write the stuff, and then you save the container. You save the VM out, and then when you want to start writing more code, you load it up again and start typing. And there's no you don't need the file system or anything except to save and load these images. So it's and you think this is very bizarre, but what it does mean is when you start your image up again, you're back in the debugger.
Right where you were.
Everything is exactly frozen where it is.
Interesting.
And that's something you don't do when you're working with source code. You kind of have to compile it and everything all the time. That's not true in Smalltalk. It's very, very dynamic, and it means you do a lot of stuff. Everything in Smalltalk is an object, including the compiler, the debugger, the stack frames, everything. And you can just go in, and a lot of people write all the code in the debugger. You write a couple of lines of code, you run it, and it kind of crashes when you haven't written something yet. And you just fix that one line and run it again, and then you go to the next line and fix it again. Almost like TDD, but in a kind of dynamic way where you're programming with live objects.
Yeah, right.
And it's, like I say, it makes it a very different experience from programming with source
You're kind of
files.
living in the object.
Yeah, you're living in it. You're swimming in a pool.
You think about a lot of the modern development practices where we basically want to be able to create and recreate on demand.
Yeah.
This is a very different way of thinking about the problem.
It is.
But it's very much, you're in the moment. You're in a dynamic system all the
exactly.
time.
And the model is there's this kind of world of objects that you're just living in, and you kind of manipulate them and play with them, and then when you come back, it's exactly the way you left it. So it's like a genuine workbench or a desktop. People use desktop and workbench metaphors, but Smalltalk really is that metaphor kind of come to life. Everything is just like where you left it.
So did you just stay out of the managed memory world for a long time? When did you...
Smalltalk's managed memory, but I mean, I never learned C. I mean, I learned a little bit of C, but I was never into that kind of low level stuff. I like very opinionated languages, so I liked Smalltalk. I really liked Python. I used to do a lot of Python. I like Prolog. I like Forth. I like languages that this is a certain way of thinking.
Right. For a particular purpose.
Yeah, they're not all. And so I kind of dislike kitchen sink languages. Like, well, you can do it this way, you can do it that way. It's a it's a dessert topping, it's a floor polish, whatever it is,
like C#, right?
Yeah.
Well, C# and
C#'s
Java.
not so bad, but I'm thinking of things like Perl.
Okay.
I'm thinking of Scala. I'm a little bit worried about C# becoming a bit of a kitchen sink language, because I think a language should do one thing and do it well, and if you try and do too many different things in the same language, it makes it very hard. I mean, C# already has a history, or .NET has a history. It's like 20 different ways of doing async.
Sure.
And then you have to know all of them, even if there's the current one, which is modern. When you're looking at old code bases,
you got to see the old ones.
You've got to see all the different old ways.
Well, and Microsoft's always been big on not breaking old code. So they'll never take it. Once they ship a feature, they'll never take it away.
Sure.
Yeah, I mean, and .NET before generic, so sometimes you have non-generic arrays and sometimes you have generic arrays. And,
what do you think about these immutable collections in terms of when you would use them and why you would use them?
I think immutable is great. I mean, in F# actually has its own collection library, so we tend not to use the .NET libraries too much. We use the array and so on, but it has its own immutability. Immutability is... I actually did a talk here at NDC Oslo about F# for C# developers. And one of the points I make is that one of the goals of F# is to have very predictable code. So the idea is you look at a piece of code and you can tell what it does without looking at the documentation, without having to drill into the source code and find the implementation. It's
very legible.
Here is what the code... It's just like, I can see what it does just by looking at it. So that means no throwing exceptions, means no nulls because they're invisible. Right. It means like, if I have something and I pass it into a function, so let's say I have a collection of customers and I pass it into a method that does something. Right. When it comes out, has that collection been changed?
Right.
I don't know. I can't tell. Maybe that collection is empty. I thought this was full, and I call this method that I don't know what it does, and it comes back, and now that collection's empty. It's like, how do I know that?
Right.
So if in a mutable collection I pass in, I guarantee it hasn't changed when it comes back.
So, it does beg the question. I mean, okay, let's say one of the functions is to create a new customer. So now we have to add a customer to our collection.
Right.
If it's immutable, I can't do that.
That's right. So a function that, let's say I have a method that adds a customer to that collection, it will return a new collection. But the thing is, it's now very obvious. So I look at the source code and I say add customer.
Yeah.
It actually returns a new collection. It's really obvious that it's doing something to the collection that, rather than just changing behind the scenes.
So that's the idea, is that it's not that you can't change data.
Yeah.
It's that the structure underneath doesn't change. Strings in .NET are immutable.
String. Wouldn't it be awful if I passed a string into a method and I wasn't sure I was getting the same string back?
Right. Yeah.
Just mess with it.
I mean, and actually a good example is date time. In .NET, date times are immutable, but I think in Java they're not.
Right.
And people have all these things where somebody's messed with a date time. And, I mean, integers are immutable. We don't expect that if I pass an integer into a method, it's going to come back as a different integer.
Right.
So in other words, you return a new string every time.
Exactly. But the method, it makes it very clear, because now rather than returning void, it returns a string. So I can see I pass in a string and I get a new string back. So I can tell that it's doing something just by even looking at how the method is designed.
Right.
Yeah. And I like that certainty. That you kind of know when a new thing's coming in.
Yeah, and I know, especially I have confidence that the old thing hasn't changed.
Right.
That's worth a lot. I mean, here's another good reason for having immutable stuff. Let's say you've gone to this trouble of validating a customer. It's like, is the name right? Is everything okay? And I pass it around my program, and then sometime later I need to use, is it still valid?
Yeah, right.
I don't know. Maybe somebody's changed it. If it's immutable, once I've validated that, I never have to check it ever again.
Right.
Yeah, multithreading is another good reason to have immutability, and this is the big problem with locking, right?
Yeah.
So in object-oriented programming, when we have multiple threads, you have to lock an object like a collection.
Yeah.
Because if it changes, you're screwed.
That's right. And you can never... If it's mutable, I mean, you can say, well, they might have locked it, or they might not have.
Yeah,
How do I know?
have to trust
I don't
someone
know.
else
I have to
done it right.
trust someone else's code.
Yeah,
and that's the thing about predictable code. If it can't be changed, I guarantee you can't break it, no matter how bad you are.
Yeah, right.
And also it stops. I mean, you talk about, well, somebody else does something stupid, but of course the person who's going to be doing something stupid is you.
Yes.
Right.
And you're going to be doing it at like 2 o'clock in the morning because you're in a hurry to get something out the door, and 6 months later you're going to regret doing something stupid. So I like languages like this because it stops me doing something stupid. When I feel lazy, it's like, don't do that. You're going to regret that later on.
Yeah, it was Brian Hunter who said that it's sort of like the the bar going into a parking lot that says you have to be
below 6'6",
below 6
Yes.
foot in order to get in here.
Right.
And
Right.
if you know that it's not going to work, you don't do it.
That's right.
So it's a preventative thing.
Yes, it's a kind of a safety
It's a
thing.
safety
and
mechanism.
when you
Same way as static typing, right?
It's same
Yeah.
with static
The
typing.
compiler
And
will tell you you're wrong.
when you're new to it, you feel this is a burden. It's like, it's telling me, the stupid compiler won't let me do this, the stupid compiler won't let me do that. And it's, after a while, it's like, so initially it's kind of frustrating, it's kind
Right.
of annoying, but when you get used to it, it's like a security blanket. It's like, oh, thank God, this thing caught the.
It's a whole class of problems you don't have to
exactly.
think
And
about.
it lends itself nicely to functional programming because functions return values. And
Yes.
it may return a new value.
Exactly. I mean, that's why functional programming, immutability has always been a part of functional programming because
Right.
a pure mathematical function doesn't change anything.
Sure.
Yeah.
All deterministic behavior, right?
It's sort of completely deterministic, right?
And since we're all old guys here, and we already started down the old guy path, it's not unreasonable to say, why did object-oriented development win in the 90s?
That's a good question because I remember when object-oriented programming was new.
Yeah.
That dates me.
And there was also that battle in the 80s.
and people saying, "Oh, this newfangled object-oriented programming stuff.
Right.
I don't know. It's all a
This
bit
is not
weird."
efficient. Yeah, well, it was that whole declarative versus imperative.
Yeah.
Like that was the argument
Yeah.
back then.
You had-
Multiple inheritance.
Yeah,
Oh.
they had all sorts of stuff. That's a good question. Why? I think first of all, functional programming was still very academic.
Yep.
And I think object-oriented programming has always been much more sort of user-friendly.
I also looked at it. I thought it utilized the hardware better. The side effect of immutability is you
Yes.
tend to copy a
Yes.
lot of memory around,
Yes.
right? Because you never modify memory.
Yeah.
Where the object approach, you tend to conserve memory. We're all working on the same piece of memory
But
over
it's
and
also
over
the
again.
way our
Yes,
brains
yeah.
work, right? We like
Yeah.
to encapsulate real-world domain
Yeah.
things into things that we
Yeah.
can tinker with.
And the words, object-oriented
state.
is trying to. The whole idea is you emulate the real world.
Yeah.
You have and the words that if you look at the object-oriented patterns, it's an adapter pattern, it's a strategy pattern, it's a factory pattern. If you look at the terminology in the functional world, it's a monoid and it's a functor, and it's it's a little more off-putting.
You sure?
Yeah.
A little
Right.
esoteric.
Yeah.
I think, as a guy with a strong hardware background, when you started seeding, I'm thinking about old functional language like Scheme.
Yeah.
When you sat, or even Prolog, you sat that beside C++.
Yeah.
It used less memory and it ran faster on a single-threaded machine.
Yeah.
And then in the 2000s, the hardware shifts on, we have more memory we know what to do with.
Right.
Yeah.
And the CPUs are up to their eyeballs in cycles.
Right.
And suddenly those constraints that gave object orientation an advantage aren't there anymore.
Yeah.
And the costly part of object orientation, which is the mutex
Yeah.
and
Yeah.
locking strategies, that becomes the expensive part. And we
Right.
want to program a different way.
Yeah.
And then we fumble around for a long time trying to come up with different parallel execution paths for objects until we kind of figure out, maybe it's the object that's the problem.
Right.
Right.
And the parallelism is one thing, but also one of the things about object-oriented programming is dependency management.
Yes.
That's that is like the number one pain now for everybody.
Right.
But I think we should just acknowledge inheritance for the most part. It's just a bad idea.
Yeah.
Well, it's not just inheritance, but every object can talk to every other object.
Yes.
And Joe Armstrong, Erlang guy, has a great quote. He's like, "I wanted a banana, but I got the gorilla in the whole jungle." It's like, I just want this one little thing.
Hold that thought while we take a moment to pay the bills. This episode of .NET Rocks is made possible in part by Windows on the Google Cloud Platform.
What? Isn't this a .NET show?
Yeah, .NET runs on the Google Cloud Platform, man.
Everything in .NET?
You bet. All the .NET Core libraries and more, including 200 plus Google.com and cloud services. Hey, John Skeet's behind it. He's a genius.
The John Skeet? The Rescue the Princess John Skeet from Stack Overflow?
Yeah, the one and only. You can deploy your ASP.NET Windows apps to Compute Engine or your ASP.NET Core apps to App Engine or Container Engine, which is Google's hosted Kubernetes environment, and it runs like, well, Google.
What about Visual Studio integration? Oh, it's there. I'm reading it now. You can use Visual Studio to manage your GCP resources and deploy your existing apps.
Yep, you can get stack driver logging, error reporting, and tracing support for .NET and .NET Core.
Also, there are PowerShell commandlets for GCP, which run on Windows and Linux.
And if you need help, there are a great set of partners to get workloads to GCP, including Capgemini, Nudezic, and Magenic.
So go to gcp.netrocks.com and get your free trial today.
.NET on Google. Who knew? You're listening to .NET Rocks with Carl Franklin and Richard Campbell, and Scott Wlaschin is here. We're talking F# and functional programming and bananas and gorillas. and there was a great quote. I think Don Box, I saw this on his Facebook page once. He says, "I had a problem, so I used Java, and now I have a problem factory."
Yes, exactly. Yes. Yeah.
You're expecting, and now I have two problems.
Exactly.
Now I have a problem.
That's a great quote. Yeah.
Yeah, it's a great one. But it is very interesting to think that languages reflect the hardware of the day, and then hardware changes and the languages don't automatically catch up.
Yeah, yeah. I mean, there was object-oriented programming, Java especially did one good thing, which is it introduced managed memory and a VM.
Take all that stuff off the table.
Yeah, and so, because there was a big thing, garbage collection is terrible. And garbage collection was relatively slow, when it first started. Yeah. But now that's fine. All modern languages, well, not all, but it's considered that unless you're doing systems program, garbage collection is fine.
Yeah, we have a lot of memory.
It broke through that barrier.
Yeah.
And functional languages pretty much need garbage collection.
We were doing garbage collection in Quick Basic. I mean, that was, but you could just create string, and that was one of the big things about Basic.
But it was kind of a big deal, too, when you ran that you better time it right, because the machine's going to go away for a while.
Yeah.
Well, Lisp and Smalltalk always had garbage collection, too, but they were always considered slow and heavy. I remember the first Smalltalk program, it used 2 meg of memory.
Dun, dun, dun.
Exactly, and it's like, oh my god, that's 2 meg of memory. Oh my god,
What are you doing with all that memory?
And now it's like, like one tab in Chrome is like 50 gigabytes.
It's crazy. Isn't it crazy?
It's crazy, yeah.
Yeah. How many don't look at that task manager; it's just going to make you angry.
How many copies of Chrome.exe do you have running?
Well, I'm going to look right now.
So I mean, it's just the expectations have changed so much.
Yeah, it's pretty funny. Yeah, and it's just, again, the hardware is continue to improve, and we can now address a different class of problem.
Yeah.
When we first started talking to people about F#, it was, I think, at least my opinion at the time was that what I got out of it was kind of a mathy language and good for numerical analysis and big sets of data. And would you ever use it for, off-the-shelf software?
Forms over data.
Yeah, forms over data. And I think it was Ted who said, yes, we use it for everything. And, then other people would come on and say, nah, not really. So what is the consensus here in 2017 about using F# as a standard all-purpose?
I think it's a fantastic all-purpose language.
Yeah.
I just did another talk here at NEC, which is on using F# for domain-driven design. Mm-hmm. So domain-driven design is sort of the least academic.
It's also very object-oriented.
Yeah, it's considered very object-oriented. Yeah. But it turns out that the type system F#, what they call algebraic type system, so it's a jargony word, but it's extremely good for modeling business rules and for modeling data structures, and it's very, very expressive. And because it's very concise, you can actually fit a whole domain onto like a couple of pages. So you now have code which is kind of executable documentation. It's one of the dreams of kind of Agile. It's like the code is the design and the executable documentation, and don't try and have separate things. Funny enough, functional languages I think achieve that better than object-oriented languages.
So in F# you said a couple of pages. Is that like a module or what we would consider a class file?
Yeah. So the example I give is like, let's say we take payments for an e-commerce site, and we say, okay, we take cash, we take checks, and we take credit cards.
Yeah.
So now, if I was doing an object-oriented language, I'd have like a base class or an interface or something, a payment method interface, and then I'd have like 3 subclasses for each one. In C# I would now have 4 files, because I'd have a file for each thing.
Yeah.
Right.
In F# I'd have 4 lines of code.
Right.
And if I then had another thing which is like a credit card type and a money type or something, I would put them all in the same file. I wouldn't have one file for every single type.
And when you say lines of code, 4 functions?
The definition of a payment method as being 3 different choices.
I see.
Would actually be, it's a type payment method equals cash or check or credit card. That's that's the entire definition.
Yeah,
like an enumeration.
Kind of like exactly like an enum kind of thing.
But you've also described a business rule.
I've described
If I want to add a new one, I just add a new OR.
Right. So it's all in one place, and all the concepts. So like in domain-driven design, the goal is to try and understand the concepts that the business uses and to have the same mental model. The developers use the same mental model as the business experts, and so you're trying to communicate that same mental model, and if you can express that in code all on one page, like we have a payment method and here's the three things, we have the kind of credit cards we take, the kind of money that currencies that we take, you put them all on one page, there's your documentation.
Yeah, no,
but it's
pretty
also
powerful.
compilable code. So I think that's fantastic.
Right. I mean, there's more code to come.
Yes, to
behind
implement,
that.
and that's one of the things in functional programming, you separate the behavior from the data.
Right.
So obviously in object-oriented programming, it's all about putting them together in the same place.
Yes.
But if you separate the actual behavior, then the implementation of how you process a payment or something, that's buried in the code somewhere.
Yeah.
But the actual concepts, the fact that you have something called a payment method, and you have something called a currency, and you have something called money, that's all up front at the very beginning. It's not
It's almost
scattered
like
throughout the thing.
in C++, a header file.
It's like
right?
exactly. It would be just like
Your
a header
list
file.
declaration. Yes.
Exactly. Yeah. I mean, a funny sort of it is. Yeah, a header file is quite a good analogy.
Right.
Yeah.
But
So it's like a header file that has everything, all the concepts that you use in the business, and that header file is written in such a way that even a non-developer can read it.
yeah, and can get these core concepts. There's
Exactly.
obviously going to be details behind it.
Yes.
Yeah,
Yes.
But the fact that you can now actually ask smart questions.
Yes.
What kind of cash?
Yes.
How many credit cards?
Right. Exactly. And
What
it's
are
all,
our rules around checks?
Exactly. So you can try and capture all that, and that's I think that's great.
They're very compelling and a great way to just think about.
Yeah.
If I'm getting ready to program functionally, I want to think in those terms.
Yes.
Of getting these declarations done up front.
Exactly.
And then going into the details.
Exactly.
So where do objects fit into F#? I mean, because it is an object-oriented functional language.
Yes,
which is
it's
kind
a
of
hybrid
strange.
language. You can do pure functional programming, and you can do object-oriented programming, and it will do both very nicely. We consider it like a functional first language, which means it kind of leans towards functional programming.
Do you
That
ever
would be
mix
first
the
thing.
two? I
Yeah,
mean,
you can, but you can totally mix. Sometimes
pass
objects
to functions.
Sometimes objects are the best way of doing something. So we're not like, you always have to use functional. It's like, purist that way.
Yeah, and then certainly within a function, you're going to make a call into an API. You're
Yes.
going to have to use objects.
Exactly, and one way we use objects a lot is we have to integrate with C#.
Yeah.
So with the integration between C# and F# is very nice because, you can make your F# code look like C# code from C#. So you just write a DLL in F# and things come through in C# very nicely. If you stick to things that C# understands, there's some things in F# that C# doesn't understand. So you just have to avoid those in your sort of public API.
Are you able to use link?
Yeah, you can totally use link in F#.
Yeah, I mean, that's a very functional thing.
Yeah.
Yeah.
And you can use interfaces, you can use objects, you can use all the stuff that C# has, you can use from F#.
All the stuff. Hey, Richard.
Yeah, buddy.
Guess what time it is now?
Must be that happy time again.
Yep. It's time to tell an immutable joke.
Oh.
I tried to change the punchline, but it got a read-only error. All right. It's actually time to give away a DevExpress D Experience subscription to one lucky member of the .NET Rocks fan club. Become a UI superhero with DevExpress UI controls and libraries, and deliver elegant .NET solutions that address customer needs today and leverage your existing knowledge to build next-generation touch-enabled solutions for tomorrow. I think touch-enabled solutions are today.
Yeah.
Actually. Or whether it's an Office-inspired application or a data-centric analytics dashboard, DevExpress Universal ships with everything you'll need to build your best without limits or compromise. Learn more and download your free 30-day trial at devexpress.com/superhero.
All right, buddy. Who's our winner?
Today's winner is Stephen Daniel Ellis.
Congratulations, Stephen.
Yes.
Golf clap for you, sir.
Yay. Stephen just won the DevExpress D Experience subscription. That's a big pile of awesome from them, just for being a member of the fan club. And if you don't know what that is, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. We have thousands of members all over the world, and every show we like to give away stuff from our sponsors, and every December we give away a $5,000 technology shopping spree to one lucky member of the fan club, but you got to sign up to win. And now we'd like to ask our guest, Scott, if you had $5,000 today to spend on technology, what do you think you'd buy?
Well, that's a good question. I have to say that I am not like a gadget guy. I actually don't really like gadgets and a little bit of a Luddite, to be honest. I really like software, but I actually don't like hardware.
Well, it doesn't have to be tech. I mean, technology is a big word.
And this is the thing. One of my personal mottos is like, be a producer, not a consumer.
Right.
So
Yes.
don't just like passively suck in Twitter. So I would probably spend that money on things related to music. I play a musical instrument.
Oh, what do you play?
I play keyboards and bass.
Nice.
And
So you
I
might
would
get a
probably-
Nord Stage 2?
I would probably get
$5,000.
something like that.
Yeah, that's a nice piano.
Yeah.
Yeah.
We have one too.
Good keys.
Yeah.
You have one?
I have a Nord Stage 2 EX and a Nord Electro 3. Yeah. Great stuff.
Yeah.
And, you know, the Nords are awesome because you can download a free app where you can just change out the samples, and there's a whole library of free samples online, and they're all great stuff. I got a story about this, actually. My brother Jay Franklin, who was... He was on the show a long time ago as a Java developer.
Because he still is a Java developer. We
Well,
try not to hold it against him.
Yeah, right. And he also is one of the editors of .NET Rocks, so he's an editor.
So he's listening right now. We're making fun of him.
No, this isn't Jay's show.
Okay.
This is Brandon's show.
Brandon will
but
tell him.
Brandon will tell him. Well, anyway, he got asked to play keyboards in a Led Zeppelin cover band.
Okay.
For 1 gig. And they were coming to New London. They were playing at the Garden. It was one of those classic albums bands. And they did all of Led Zeppelin 4.
Awesome.
And so he had to do Kashmir. Kashmir was one of the tunes that
Wow.
they did.
That is not easy.
And it turns out that the Nord library includes all of those Mellotron sounds that they used on that song.
Fantastic.
So we found the exact sound for that
Wow.
cheesy synth string thing, the Mellotron.
Mellotron, yeah.
And it was perfect. And he was like, oh, they told him, they said, we're going to hijack you. And
Yeah, you're coming with us.
Yeah.
And he was never seen again.
Yeah. No, those Nord keyboards are great.
Good machines. I mean, you literally are talking about a grand piano sound from a grand piano.
Oh, sure.
Digitized. And,
Multi-sampled.
yeah, it's very interesting.
Oh, well, talking about technology, I mean, between the 80s and today, in terms of the sampling and so
Yeah.
on, the keyboards, digital keyboards is so much better.
They
than
can do whatever they
yeah.
do whatever you want. We have
Yeah.
enough capacity now.
Yeah.
It's almost trivial
Yeah.
to be able to deal with all that. I don't know if they're functionally programmed, but
Probably not.
Yeah, maybe.
yeah,
I don't know.
It's
There's a lot of asynchrony happening there.
Yes, definitely. You definitely want no interrelations when not necessary.
Mm-hmm.
I guess one of the arguments, because when you look at from the 30,000 foot view, maybe I'm an enterprise architect or I'm a CTO. F# is a smaller adopted language. It's harder to find people for.
Yeah.
I mean, how do you make that argument for why we should go this way? What advantage is it giving us?
Well, that's a good question. There's some technical advantages which you can be more productive with a smaller team. So you save money both ways. You can get to market faster.
Deliver more features in less time.
That's always a good argument.
Right.
And we actually have some, I mean, people always say that, but we actually have some proofs. There was a team, I think, I don't know, 5 C# developers were trying to write this thing for a year, and they gave up. And then they went down to a team of 2 F# developers, and they delivered the functionality in 6 months.
Right.
Wow.
So there were quite a few. I mean, these are anecdotal stories.
Yeah, and it's always arguments either way on
Yeah.
that.
But the other thing is that the argument about hiring people, it's like, how can we find a good F# developer? When I've
With
been
20
in-
years experience.
Yeah, I've been I've been in the seat of hiring people, and it's really hard to filter out. That you get thousands of resumes.
Right.
It's really hard to figure them out.
Right.
If they have something like, if you put out a thing like we're hiring F# developers, you will get a series of really high quality people applying.
Right.
So it's a great filter. If you want to hire really good people, you say, I'm looking for F# people or Haskell people or something, or Camel people, whatever.
Right.
And you will get people who are very experienced and also who are guaranteed to be interested in learning.
Right.
Sure,
So
yeah,
if
right.
I want to hire for a team, that's the kind of, by doing that, you've got an automatic filter on
Yeah.
the thing. And the same thing for, training people in-house. It's not that hard. If you've got a good team, they will want to learn new stuff.
And it's a
way-
strong argument, too. I would rather you wanted to learn it than
Yes.
you knew it.
Yes, exactly. And I mean, if you have a good team, one of the problems, if you do have a good team and you want to keep them in-house and you don't want them to quit and go somewhere else, you want to get them excited about new stuff. You want to train them on new stuff.
Right.
And if they're good people, they want to learn new stuff themselves.
And really, all you need to do is provide them time to learn.
Exactly. And it's especially with F#, if they're already using C#, they already know the .NET libraries.
Sure. And they know the tooling.
Someone here said, I think it takes 4 to 6 weeks for someone to be productive in F#.
Interesting. And this is the session you were doing here as
Yeah,
well. It's like,
yeah.
so you're a C# developer. Here's
Yeah.
what you need to know.
Yeah.
Mark Seaman famously said about combining F# with ASP.NET, it's not trivial, but it's doable. Are there people doing ASP.NET and
Sure. I have
F#?
a ASP.NET F# app on my GitHub.
So no special gotchas there?
No,
because you're dealing with the objects of the ASP.NET.
Well, it's what's tricky is mixing paradigms. So
Right.
if I'm using, I can totally write an ASP.NET app in F# if I stick to the object-oriented model.
Sure.
Because everything in there is designed to be object-oriented. You
Web
pass in
API, no problem.
interfaces and
That's
so.
fine.
Yeah, Web API is no problem. So if you're object-oriented, it's fine.
Yeah.
It's when you switch between functional and object-oriented it gets tricky.
Sure.
There is Suave, which is an F# web framework. Is a functional web framework, and it uses functional concepts like composition and pipelining and stuff rather than the ASP.NET. So that's an alternative if you want to stay functional.
Would you be able to, let's say, do a Web API with that?
Well, you
All
basically,
functional?
rather than using the standard web API, it kind of bypasses. It has its own kind of front end.
Oh, neat.
And then the other alternative is to use like web API, the controls and stuff you do object oriented, and then when you get into the domain, that's where you switch. So your kind of internal implementation is written in a functional style. So you can you can mix and match in the same code base.
Interesting.
So the Web API has the standard put, get, and all that stuff, and it's calling into your domain, which is all functional.
Yeah, exactly.
Is it necessarily faster executing, like parallel execution? Is any of that actually true? Can you measure it?
Yeah, I've done some parallel stuff. Parallelism, I think, actually is a little bit overrated.
I don't disagree with you.
Because it's like, well, we make it parallel, and it's like,
it'll be better.
Even on the same machine, you never get a 2x speed up.
Right.
You get like if you're lucky, you get a 1.5 speed up, and if you're not lucky, you get like a 1.1 speed up.
Well, I am fundamentally writing parallel code. It's like writing plumbing into your code.
Yeah, exactly. And then you say, well, okay, we'll scale out horizontally and run on millions of machines. Like then now you have network overhead, and you have to have error handling. So I'm wary about parallelism unless you really, really, really are CPU bound.
Right.
Mostly
you
are. Yeah. And typically, in my experience, you've got bad algorithms. Don't use a list. Don't iterate over 1 million items in a linked list.
Yeah. Let's start with rule number 1.
Yeah,
you're not walking through 1 million items. That's not a good idea.
Use a dictionary or use the appropriate algorithm. That will probably give you a much, an order of magnitude speed up more than using parallelism. Make all your I/O async. Don't ever block on anything. Basic, and find your hotspot and profile it. I mean, one of the problems you do run into in F#, just like you do in C#, you tend to sometimes over allocate memory, and there's a hotspot where you're like creating millions of objects. Find that hotspot, turn everything into an array and ints or whatever, so that you don't use, so you're not doing any allocations.
Nothing fat.
Yeah, exactly.
Like
and then, but that little hotspot then is fine.
Yeah.
And then the rest of the code you can use nice things, and I think this is true for any. It's exactly the same things in the performance things you can do in F# are basically the same thing as you can in C#.
I do really appreciate the sentiment that you don't parallelism. You'd rather be asynchronous.
Yeah, I think async is the big win.
Sure.
And F# async is really, really nice because in F# async model, async is part of the type system. So when I look at something, so again, I talk about making something obvious. So if I look at a method, and it says it returns an async string, I say, oh, okay, I know that it's an async. It's going to be an async. It's not buried in the code. Somewhere.
Yeah, there's no commands for this. It's just literally this is the type of return it's going to have.
So I can tell just by looking at it what it's doing.
So I think the question on everybody's mind right now is, how many ways are there of looking at a turtle?
Well, that is a good question. I wrote a blog post called 13 Ways of Looking at a Turtle, and I have a talk as well. In my blog post, I ended up actually going to 15 ways.
Okay.
That's a lot of turtles.
That is a lot of turtles, and it's a riff on there's a well-known poem, 13 Ways of Looking at a Blackbird. So that's sort of my riff. That's why I chose 13. That was interesting because I wanted to take, when you're trying to learn new stuff, sometimes you have these really complicated domains. It's like I want to pick something that everyone knew, which is like turtle graphics. And here's lots of different ways of doing the same thing. Everyone knows how turtle graphics work.
Yeah, this is the thing where you program the turtle to
you program. You can go forward, and you can turn left,
yeah.
and you can turn right, and you can make a red pen and a blue pen or whatever. And that's it. And you can draw little shapes, kind of like Etch-a-Sketch or something.
Logo, I think.
Logo was the original turtle graphics.
Turtle graphics, yeah.
And it's a great way. It's really, really simple, and you can do quite cool things. And you know, as a way of learning programming, it's great for kids because they can see a real turtle.
Yeah.
Sure.
So
When you say real,
yeah, well, you actually had. I think they really had a real turtle that moved around on the ground. It's not a real turtle. It's a toy turtle.
Yeah.
Anyway, okay. So in this thing, I started like with an object-oriented turtle, and then a functional turtle, and then a turtle, an event-sourced turtle, and you know, a state monad turtle, and a all the different kinds of things you can do with this model.
Dependency-injected turtles?
Dependency-injected
Nice.
turtles, that's right. And I had a
Abstract data turtle.
I mean, I had fun with it. It was kind of silly.
It's pretty awesome.
Yeah, and it's interesting because you can see how the techniques change in these different things.
Sure.
And obviously, it's overkill. I mean, to like have an event-sourced turtle may be totally overkill for this
a bit
model.
much.
But you know, and sometimes it
Well, you also, when you talk about deliberate practice, and we've had this conversation with Mark Seaman before.
Sure,
like,
yeah.
Because all too often as programmers, we're only doing the work.
Yeah.
We never go out to do practice in the sense that, you're both musicians, so you know what deliberate practice is.
Right,
playing scales is not playing a song.
Right.
It is practice.
Right, Yep. right.
So to take a simple programming problem
Right.
and to exercise your skill
Yeah.
a dozen plus different ways,
right.
that's deliberate practice.
Yeah.
Yep, sure is.
Yeah, and it's a great way. Yeah, it's fun as
Yeah.
well.
It is fun.
Playing scales isn't fun.
But, and again, and I've said this so many times, it's like, I respect the ability of musicians, especially watching Carl for many, many years, because I watch him practice. I watch him earn his skill.
Right.
Yeah.
Right. And I feel like as developers, that if we spend a little more time earning our skill,
Yeah.
so many things get better.
Yeah.
It's
And
a confidence builder.
It's even this, too, that after, when you first start playing scales when you're learning an instrument, you don't see your progress
Right.
immediately. But, now after 30 whatever years of playing guitar, I can sit down and with, my hand isn't loose or limber, and within 10, 15 minutes of playing scales, I'm flying all over the
You're
fretboard.
playing better.
And I can see that I'm playing better.
Right.
So, and programming is the same way. The more seasoned you get, the less time it takes to learn new things, to adopt new patterns.
Yeah.
And, you can see the benefit, right?
But also to be aware when you're not pressing against the edge of your skill, too,
Yeah.
right? I mean, that's I think the bigger thing you said there is like, I know I'm not playing up to snuff. My hands
Right.
are stiff.
Right.
Right. And I wonder if you can look at code and go, this is not the best code I've written for this problem.
Right.
That you actually want to be better, can know where your edge is.
Right.
Yeah, and the more exposed, the more different paradigms you understand, the more different techniques you know. It's a toolkit.
Sure.
So that you have, if you only know one thing, if everything's a hammer and everything's a nail,
Right.
it's like the more different things you know, it increases your confidence, and it makes you. It's like, well, like in this situation I'll do this situation I'll do that.
Yeah,
and
I've got a dozen ways to knock that nail down.
Exactly,
If
right,
he
exactly.
doesn't like my hammer? Fine.
Right.
Introduce me to Mr. Brick.
Right.
Like, there's ways to solve the problem.
Exactly, and I think that's
an
part.
abstract data nail. And,
There you go.
I'm looking for an event-driven nail here.
Yeah.
It also seems like an interesting way to explore a new language too.
Yes.
Because you're coming from C# and you've sort of done quote unquote traditional C#, because I've definitely seen very functionally written C#.
Yeah.
To then you're going to tend to take your C# workflows with you to
Yes.
F#.
Yes.
And then complain that F# not that good.
That's right.
Because it's trying to do C# things.
That's right. And I personally think, a lot of people, when they learn a new language, the first thing they try and do is, well, how do I do my old thing in this new language?
Right.
And I think you'll be better off forgetting everything you know. It's like, forget anything about objects, forget anything about inheritance, pretend you're a complete beginner, and then you've actually got a lot better chance of learning, because a good language encourages a certain way of thinking.
Right.
And if you bring an old way of thinking to it, you're actually going to get very frustrated. Like, mutable variables and stuff. It's just, there are things which are really awkward to do if you're trying to do it in an imperative style.
Right.
The language really doesn't want you to do it that way. And if you're fighting the language, that's telling you something. Rather than getting frustrated, you say, I'm obviously doing something wrong. Let me try and figure out what the right idioms are in this language.
Yeah, presume it's you.
Yeah,
That
exactly.
there was an intent here, that
Yes.
people have been successful with
And
this.
if other people, and the other thing is to look around you, and it's like, are other people doing this okay? It's like, what are they doing that I'm not doing?
Right.
yeah.
And I have noticed that the F# community, and maybe it's because it's as small as it is quite diligent about caring for its own and in bringing new people
Yes. Yeah, we're super friendly. Yeah.
in. And you kind of need to, because not a ton of you.
Not a ton, no.
Your blog is a really good example of that. F# for fun and profit. There's great graphics here about how you the way that you show things with screenshots and videos and stuff. It's just very approachable.
I'm a very big fan of using pictures. I mean, we stare at code all day long, but I actually think in many situations, a good diagram is worth 1,000 words. It's like you can explain things, and it also makes it fun to read. Right. And I try and use on my blog. I try not to use the word monad anywhere. It's like I have a list of banned words.
That's great.
And monad is one of them.
Yeah.
And you have an official ebook?
I have, yes. People asked me they wanted to read the blog offline.
Right.
So I went on to Gitbook, which is really nice. And Gitbook is, my blog's written in Markdown. Gitbook uses Markdown. So I just had to tweak it a little bit, and I just upload it to a Git repo, and it turns it into like a PDF file.
No kidding.
And so you can read it offline. And I thought, well, a couple of people would want to do that. It turns out there's a lot of people who want to read it offline.
Yeah.
If they're commuting or something, So, the Gitbook's been very popular.
It's really interesting that just sort of make it that way. And the fact that people want to do that, too.
Yeah, I was shocked, actually. I thought, who wants to, but yeah, a lot of people do.
Well, the story is the Martian, Andy Weir.
Yeah,
originally wrote the book as a series of blog posts.
That's
so
right.
I think it made into a movie.
Right.
He wrote it as a series of blog posts. People were like, hey, I don't want to read on your blog. Do you mind putting it together into an e-reader file?
Right.
So he puts it together in an e-reader file, and then finally well, geez, it's even too hard to sideload that. Would you mind putting it in Amazon? So I could now it can't be free because Amazon insists on a certain number of pennies. So now he's charging $1 for it.
Yeah.
And then he still sells. He sells tens of thousands of copies, like many more than anybody ever downloaded it off the blog.
Right. Yeah.
You know what? Convenience of delivery.
Yes.
It's very interesting.
I have actually thought about putting my blog on Kindle just because, for people who just want that. It's just one less thing to think about.
I do read periodicals like Foreign Affairs and the MIT reports off of Kindle for exactly that reason, because it's offline in the airplane. Right.
Yeah.
It is.
It's
good
easy.
to go.
Yeah, exactly. Yeah. It's worth a couple of bucks for the convenience. Really.
Sure, 100%. I'm willing to pay for that just to lower the bar. If you're willing to buy a cup of coffee.
Exactly. It's the same price a cup of coffee. I mean, how can you complain about it?
If I spend an hour with a cup of coffee, I'm not that happy. Well, but an hour with a good magazine, I'm pretty happy with that.
Exactly.
So it's very interesting what delivery mechanisms work.
And what also surprises me is, looking at the analytics for my blog, there are people all over the world. I was also surprised because you tend to think, your friends will read it and people you've met and stuff. No, I have people, obviously in Europe and America, but, in Afghanistan and in like Africa and places all over the world.
It's got to be very search driven.
Yeah, I mean, the internet is
people
a wonderful thing.
For answers.
People talk about how the internet, kind of flattens everything and everything is accessible. It's like to actually see it in practice.
Yeah, and be part of that creation.
Yeah, it's wonderful. It's actually a very nice feeling.
A very, very compelling aspect to it. Any other bits, folks who are considering jumping into F#, places to start, things they need to worry about, especially as they're coming from the C# world?
Well, the fsharp.org is the main website for F#. That's the F# Software Foundation.
Right.
And there it has instructions on how to download F#, and it has resources, various libraries, and so on.
And just to be clear, you don't have to own a copy of Visual Studio to get F#.
No, F# is open source, it's free.
Yeah.
If you're on Linux, for example, VS Code with the Ionide plugin. So VS Code obviously is cross-platform, and Ionide is the plugin that makes it support F# syntax and so on. Highly recommended if you don't want something heavyweight like Visual Studio. Visual Studio Community Edition is free anyway. Yes, there's lots of libraries. There's an F# Slack channel. If you join the F# Software Foundation, which is free, you get invited to the F# Slack channel, and there's a beginners area, and there's all sorts of stuff.
Yep.
Twitter is a great place. You put an F# hashtag on Twitter, and you're guaranteed to get retweets. Just go on Twitter and say, well, I want to see if this is true if you people retweet F# hashtags.
Right.
see how many retweets you get.
That's cool. That's cool.
Well, we'll have to put F# tags on this show when we publish it.
Yeah,
right?
there you go. Yeah.
Absolutely the case.
I like the, you have a blog post here, why use F#? And it's not just text. You're actually showing code and saying, look at this. Look how awesome this is. Not cluttered up with coding noise like curly brackets, semicolons. Really consider that noise like ceremony.
Yes.
Right?
Yeah. Just anything which isn't explaining anything. I mean, curly braces and stuff, to me, they don't add anything.
Right.
I've used, a lot of programming languages. If you come from
They
C
just use
languages, you think that's the way it is to be.
Sure.
But if you know Smalltalk and Prolog and Python, it's like, you don't need curly braces.
Yeah. A lot of them just use indenting.
Yeah, indenting. That's what you need.
Yeah.
Yeah.
Yeah, and it's interesting when you think about a language like C, where indenting isn't code.
Yeah.
You do it for clarity,
Yeah.
Right.
but it's only discipline.
Yeah, and there's bugs.
Right.
I mean, that classic, well, I think was it the SSL bug, various bugs caused by,
Bad
thinking it was indenting and it was escaping the if statement and it wasn't just because it looked like it was. And
Right.
Yeah.
Wow.
Yeah, it's very
Yeah.
interesting that's sort of the reality.
Remember the code is written for people, the compiler can figure out the
Yeah.
code.
People can't figure out the compiler.
Exactly. The code is written, when you write code, you're writing to communicate with other developers.
Right.
And so you indent your code to communicate that you've got a block.
Right.
Well, if you're going to do that anyway,
Why shouldn't it be part of the
make it
compiler's
part of the language?
understanding?
Exactly.
And be validated so that you do it consistently.
Exactly.
Yeah. I think it's a very interesting truth, as opposed to the punctuation approach, which, while the compiler has no problem with that, just like it would have no problem with spaces, it's harder on the people.
Well, I mean, look at that kind of obfuscated C competition they have,
Yeah.
right? It's like,
Right.
obviously, the compiler has no problem with it. People can't even read it.
You write some horrifying stuff. Or you can start with horrifying stuff, like Lisp.
Yeah.
Well, you see,
Languages built, or Perl, right? I've built to be uninterpretable.
Perl is fine. But you see, think about Lisp.
The cartoon swear.
Yeah. Lisp is okay, but it's very hard to write obfuscated F#
Right.
and obfuscated Python because of the way. So to me, that's a big plus.
It's a really interesting aspect on the whole thing.
Yeah.
So the async keyword is just something that you can put on any code or any function that you're calling
Yes.
in F#, right? And that's
It's
it.
not it's not a keyword. So this is one of the differences between F# and C#. In C#, to add async, they added a special keyword for async and await.
Right.
And then they changed the compiler. In F#, async is kind of like a library, as it were. It's not part of the language. It's something you could have written yourself, and they just include it as part of the standard library.
Okay.
It's just another type. Just like in the list class, it's just a class. It's not, you could have written it yourself if it wasn't part of .NET.
Right.
The async is exactly the same. It's just another thing that's plugged in. So
Yeah.
you can use all the standard language tools with it. And what it means is F# is much more extensible. So if you want to have another, people use the same technique. There's a fantastic library called Embrace, which is kind of a cloud-based distributed thing. And basically they wrote the little thing called Embrace. And that's their keyword, as it were. And you say, embrace this, and it does, you write some code, and it distributes the code that you write all over the cloud. So
Wow.
you say, let's say you want to say, I want to loop through this list. I've got a million items in this list. I want to loop them in the parallel. You just wrap it in an embrace block, and it will take those million things and spin up a million, however many machines you've got running. It will take that task and spread it over those things, and it's done using something. They didn't have to change the compiler or anything.
Wow.
You get that for free.
Wow,
Very
very
cool.
cool. Very cool. One more thing. As a musician, have you done any audio programming in F#?
No, I'd be interested to do that. There's somebody who has done it though, but that's something I don't. No, I haven't done that myself.
Yeah, that'd be interesting. I know there's I use N Audio by Mark Heath.
Right.
Mark Heath.
Yeah. I've heard that's good.
Yeah, it's great.
Yeah.
And I use that in C# all the time, but I just wonder how you might approach that in F#.
Yeah, well, if you're using a library like that, you can totally use it from. Presumably, you could use it from F#
yeah,
just like
sure,
anything
of
else.
course,
so,
yeah. But I just wonder if there's any benefit to doing. Of course, there's a benefit, to doing digital signal processing, that kind of stuff.
I don't know. That's a good question.
Right.
Yeah, there is one thing. There is some libraries for F# that work with GPUs and CUDA and stuff. So you can actually write your code in F# and it will compile it to something that's run on the GPU.
Like, think about Echo or Reverb.
Yeah.
That seems like a very good solution for F# because that's basically doing a function on audio and changing it over time.
audio. The model of how you do audio processing is exactly this kind of pipeline thing. You run it through this filter, then you run it through this filter, and then you tweak it like this, and it's like, that's functional programming.
It is.
Like that.
Yeah. Well, this is great stuff. Scott, thanks very much.
Okay, excellent.
It's been very enlightening.
Yeah, fun to talk to you, man.
And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got a transmitter banned by the FCC.